Hi again, year 3. This is lesson 4, and we are going to be looking at how to use commutativity, or the law of the commutative law, to help us in multiplying today. So just a quick review, what does commutative mean? So I have put here 2 plus 3 equals 5. Now, how can I show this equation again using the law of commutativity? What do you think? If you said 3 plus 2 is equal to 5, then you are spot on. And that is my law of commutativity. It's saying that even though I have the same add-ins, I've put them in a different order. So let's look to see if this is true for multiplication as well. So this time, I'm going to do 2 times 3. 2 times 3 is equal to 6. 2 groups of 3. That's what that's saying. 2 groups of 1, 2, 3. 1, 2, 3. There they are. Now, my law of commutativity, I would swap places of my factors. So this time I'm going to put 3 groups of 2. So 1 group, 2 group, 3 group, 1, 2, 1, 2, 1, 2. That is still equal to 6. So you can see here that these represent our laws of commutativity. In this case, for addition, my add-ins have swapped, but I've still gotten the same sum. And this time, for multiplication, my factors have swapped places, but I'm still finding the same product. So it shows that either way works out. Now, how is this helpful for us? Let's find out. So this is showing it in a different way now. I've now taken 14 times 2 and shown its commutative of 2 times 14. So this first equation, it's saying 14 groups of 2. So I've actually drawn out 14 groups of 2, and it has taken me a bit of time. And my 14 times tables are not that great. So, goodness me. But then I can think about it, well, what is 2 groups of 14? So I've shown that. 1 group, 2 group, 14. Oh, well, I know that this is 14 plus 14, and that is equal to 28. Whereas here, I'd have to go 2 plus 2 plus 2 plus 2 plus 2, carry on, carry on, carry on, counting in twos. So it might take me a while, where it's much easier and much more efficient to do it this way. So you can see already how our law of commutativity can help us with multiplication. Now, I'm sure you've noticed in your packet though that this can look a bit differently as well. So let's take another look. So let's start with this. Here I have 2 times 2 times 2. Now looking at that, you might think, oh, well, this is 3 2s. I know that 3 groups of 2s is equal to 6. Well, this is not the case. That is why it's very important to really check your equations and what it's asking you. So let's do this step by step so you can see why. First, well, they're all the same, so it doesn't not matter where I start, but I'm going to do 2 times 2. We know that 2 times 2 is equal to 4. I'm going to carry this equation, the rest of the equation down, bring it down. So now I have 4 times 2, and that is equal to 8. So you can see here that even though it looks like it's 3 groups of 2, 3 groups of 2 would be this. This is saying I have 2 groups of 2, which is my 4, and then another group of that. So I'm going to mirror it so you can see here that that is my 8. Whereas this is your 3 groups of 2, which is 2, 4, 6. Very important here that you are paying attention to what it's asking you. Let's take a look at this now with another equation. Right, this time I have 2 times 3 times 4. Now I could draw an array, but I know that your times tables are getting amazing at the moment. So we're going to use that knowledge to help us solve this. Now, again, you can use your commutativity here to help you solve these more effectively and efficiently. So the first one, let's just try and have a go. I'm going to start with 2 times 3. So I know that is 6. 2 times 3 is equal to 6. Bring this down. 6 times 4. Ooh, I'm going to think, what's 6 times 4? Well, I know that 4 times 5 is equal to 20, so I would add another 4, so that is 24. Now you can see here, I've had to do a bit of problem solving and a bit of thinking there on how to solve that. So let's try to do this equation again in a different order. Right, so I have the same equation, but this time, instead of doing 2 times 3, I'm actually going to do 3 times 4. Now I know straight away 3 times 4 is equal to 12. Bring this down, so now 2 times 12, oh, well, I know that's equal to 24 straight away because of my double facts. Now you can see here in the second equation, I've actually been able to solve that much faster because I have strong times table knowledge here on 3 times 4 and then my doubles. And sometimes it is easier doing these if you first multiply your 2 factors with the greater value. So in this case, 3 and 4 have a greater value than 2. Now, why not? Just for fun, let's see the other way of solving this. So our other way of solving this now, I've done 2 times 3, or I've done 3 times 4, so let's actually do 2 times 4. So 2 times 4 is equal to 8. Now I'm going to bring times 3 down, and now 8 times 3, again, oh, what are 8 times tables right up to? Oh, well, I could use my commutativity. So 3 times 8, or 3 times 8, I know, is 24. There we go. Now, as you can see, we've solved this equation, this one equation, we've solved it 3 different ways. Now, personally, this way was more efficient for me because I know my 3 times 4 really quickly and I know my double stacks. I have very strong double stacks. It might be that you have very good, your 3 times tables is stronger than your 4 times tables, so that one was faster than you. It might be that actually all of them were equal amounts of easy for you, and that's terrific. But do have a think, which one is the fastest for you? Which one do you see straight away and helps you solve it? And this also just shows you that you don't have to do it in this order. You can look around and see when it comes to this, because we're using times and times, it does not matter the order of which one we solve because it is showing you the law of commutativity. They are all factors and we can do it in different orders, and it does not matter because we get the same product in the end. Now I'm going to do this one more time with another equation just so we can get some extra practice. All right, here we have another example. So each equation says 7 times 5 times 4. So let's start with this one and just solve it in the order that it's doing. So first, I'm going to start with 7 times 5. Now, some of you might know your 7 times tables, but I can use commutativity. So what is 5 times 7? Perfect. 5 times 7 is equal to 35. Now I need to bring down the rest of the equation. That's 35 times 4 now. Now this is where it gets a bit tricky. So we could use our 35 plus 35, and then double that. So 35 plus 35, that's 70, and then double the 70, so that is equal to 140. Now, that was a bit trickier, so let's see if we do it a different way. Let's try this time, 5 times 4, starting there. 5 times 4, already, I know that that's 20. Bring down the rest of the equation, 7 times 20, well, again, so I know that 7 times 0, once, is going to be 0, and I know that 7 times 2 is 14, so therefore, 7 times 20 would be 140. Oh, that was much easier for me because of my double facts. Because if you know that 2 times 7 is 14, then you know that 20 times 7 is 140. So already I prefer this method than this one, because that was a bit tricky, 35 times 4. And let's try it one last time. So this time, let's do 7 times 4. So 7 times 4 is, perfect, 28. Now we're going to bring the rest of the equation down. So now we're going to do 28 times 5. Again, that is a bit tricky. Might have to add here. Ooh, let's see. So 5 times 8. Well, that's 0 in the ones because that's 40. Take that, carry that. So 5 times 20, that's 100. I have my 4. Oh, so that's 100 plus 40. That's 100, 140. And actually solving it the other ways has helped me solve it there. But you can see here that this middle one, doing 5 times 4 to find 20 and using the times tables that you know really well, helped me solve that much faster than the other ways. I was able to do it the other ways, but this middle one, using the timetables that I already know really well, helped me solve that most effective manner. Now, let's just show you what that means in your packet really quickly. So this is the activity in your packet. You have 2 equations, and what you need to do here is just explain it a bit. So here's your equation, and then here you would put what the product is once you find it. So it says write only the answers to the product after you've calculated it mentally using the other steps. So it says first item, this is going to be the first 2 factors that you multiply together. So for example, in mine, I'm going to look at the middle one. So I would say first I multiplied 5 times 4, which is equal to 20. Then I multiplied 20 times 7 because that's left over, and I used my double facts. So I knew that 7 times 2 was equal to 14, so 7 times 20 was equal to 140. So again, you're going to look at this, try to think which one's going to be the easiest for you. If you want to even do it all 3 different ways, that's absolutely fine. And have a think, which one was the best for you? Which one worked out? And enjoy that. Again, just use some different methods. And the most important part is that you understand the law of commutativity. Super. See you tomorrow. Bye-bye.